Hey guys, in today's video we're going to continue our journey of seeing if I can persuade you that right now you don't exist, and today we're going to do it by looking at quantum mechanics. So yeah, wish us luck. So how am I going to be able to use quantum mechanics to try and persuade you that right now you don't exist? Bearing in mind the vast majority of you are going to be sitting there going, I've got pretty good evidence, mate. So let's just have a very quick recap about atoms and matter, so those of us that are going, I'm here mate, we can look at what the actual atomic structure is. We've got an animation to do this. We're going up in the world. Yeah, okay, roll it. No, fantastic. Whoa. Seriously mate, what the f*** is that? We've spent all the budget. I'll just roll it, just get on with it. The fundamental feature of the electron is it is negative, as in it is negatively charged. It also has virtually zero mass. The centre of the atom contains the protons and the neutrons.
You can do this. You can do this.
And these are positively charged and neutral charged, but they both have mass.
You can do this. You can do this.
Both the proton and the neutron can break down further again into quarks, of which there's two types. The up quark, which is positively charged, and the down quark, which is negatively charged.
You can do this.
In the proton, you have two up quarks and one down quark, and in the neutron, you have two down quarks to one up quark. And when we take the sum of the charges, the two up quarks to the one down quark makes the proton positive, and the two down quarks to the one up quark in the neutron balance out to give us a neutral charge. So it's the nucleus of the atom that gives it its mass, and then there's a cloud of electrons that orbit around to produce all of the atom. Now as you will see, most of atoms contain nothing at all. It is noted that if the nucleus of an atom was the size of a grain of rice, you could place it in the centre circle of a football field and the electrons would be orbiting around in the stadium, and in between the electrons and the nucleus is nothing at all. Atoms is basically space. I have absolutely no words to describe the atrocity that I've just witnessed, so thank you for that. So quantum mechanics sometimes gets described as God's Lego set, because there's four fundamental particles that we know about that can't get broken down any further, which is the electron, the up quark and the down quark. And there's also a fourth one, which is the neutrino, but because neutrinos don't really interact with matter that regularly, we're just going to ignore them for the simplicity of this video, if that's okay with you guys. To give us an idea of how small subatomic particles actually are, think of a grain of sand. Now, contained within one grain of sand are more subatomic particles than there are grain of sand on Earth, allegedly. One of the constants I need to bring your attention to is something called the Planck length. Now, the Planck length is the smallest measurement in length that we can make. There's no point in having a half Planck length, because the Planck length can contain the smallest things that exist. So going smaller has no value. Heisenberg came up with something which is now known as the Heisenberg uncertainty principle. The part of the uncertainty principle that I want to bring your attention to today is there's two values which are linked together relating to particles. The more you know about a particle's location, the less you can know about its velocity. The more you know about its velocity, the less you can know about its location. It would be impossible to be a speed cop in the quantum world. What do you mean you've got footage of speed cops in the quantum world? Shut up. Really? Yeah? Prove it. Oh, this is going to be fun.
Whoa! Wah! You stop right there. Have you got any idea how fast you were going? No. Have you? No. Come on, Ma. Free to go, yeah. Yeah. Okay. Wait, we got another one. Where'd you go?
Seriously, dude, where are you getting all this stuff from? Oh, right, yeah. You're connected. And we should be showing them more respect? Yeah, why's that? Because they uphold the quantum law. I'm really glad I asked. So let's see if I can start to break down your arguments about particles and how real you must be because we can touch things. If you're unfamiliar with the double slit experiment, you're really in for a treat. We've got an animation of the double slit experiment. Am I going to be embarrassed by this? Oh, I'm going to be surprised, am I? I doubt that. Roll VT. In the double slit experiment, there is an electron gun which will fire electrons singly, one at a time, down a track towards a barrier. Now this barrier is going to have two slits in it, which are a lot closer than the ones that are being demonstrated here. As the electrons come along, they can either go through the slit on the right, the slit on the left, or they could bounce off the barrier. Further down the track, there's going to be a receptor that's going to mark the location where the electrons hit this wall. More electrons will be fired down the track. Because it's firing through two slits, we'd expect the receptor to show they're hitting the wall in two parallel bars. However, what was noticed was a pattern more like this. And this is indicative of an interference pattern. And interference patterns are more noticeable with waves. So if the electrons are being fired singly, how are they managing to produce a wave interference pattern? Yeah, I've just got so many questions, but the main question is, how could it produce an interference pattern if we're firing a little bullet of matter through a gap? What's interfering with it? What is it interfering with? Interference patterns are produced through waves. Now if we imagine we had a wave going through the double slits, and then on the other side of the slits it would interfere with itself. That's so childish. The fact that we observed this with the electron must show that the electron was travelling as a wave, went through both slits at the same time, and then on the other side of the barrier interfered with itself. Oh, will you just stop that? What we would need to do is be able to have an observer and find out if the electron is going through both slits at the same time. We've got an observer, have we? Of course we have. How have we managed this? Through your connections. Of course we have. Okay. Now let's try it again.
Hello.
Oh, you are f***ing kidding me.
I'm ready when you
Okay,
are.
hey buddy.
Ah.
No, we're over here.
Okay.
Oh,
I'm
great
ready
start.
when you are.
What we need you to do is count the electrons that are going through the gate on the left. Only the one on the left, okay?
Okay.
Yeah? You can do that, yeah? Okay. See how we get on. Fire the gun. Rubbish.
Okay. There's one. There's one. There's one. There's one.
What you need to do now is go down to the end of the track and count how many bands you can see.
Right you are then. Two. Hang on, let me count them. 1, 2, yeah. 2.
Okay, thank you. So we didn't get any interference pattern. So the electron went through the gate as an electron and stayed as an electron all the way down to the sensor. What we'd really need to do is move our observer the other side of the gate so the electron travels down as a wave and then goes through both slits at the same time as a wave, and we'll see if it interferes with itself. Don't you dare. Right, mate. No, we're still over here. Right, mate, we need to go the other side of the gate.
You are then.
No, we're still on this side. Oh, gosh. Connected, are you? Right.
Hello.
We're going to be firing electrons through that gap, so we want you to get out of the way, yeah? You don't want them going in your eyes. Yeah, don't want them in your eyes. That's like that. Oh, gosh. It's going to go blind, isn't he? Right, fire the gun. Go down to the end of the track and count how many bands you can see this time.
I can see 2. Hang on, let me count. 2, yeah, 2.
Sure about that? We were expecting to see an interference pattern of more bands.
Oh, 1 second, let me have a proper look. Yeah, it's still 2, yeah.
Right, okay, that's enough. Thank you very much.
Cheerio.
Yes, bye. Bye now. We're going to have words. As we can see, the results were rather perplexing. What did this mean? When the electrons were being fired and they weren't being observed, they created an interference pattern. Yet when we tried to find out which of the slits it went through, either before the gate or after the gate, the electron acted like a particle and gave us solid bands. Yet unobserved, we get the wave interference pattern. For this explanation, we need to suspend our belief in particles and real stuff. The electron was travelling as a probability wave. It was in all locations at the same time. And it was only when it actually hit the sensor at the end that it had to become real and made its dot on the screen. When it was travelling as the wave and it was observed, using Heisenberg's uncertainty principle, we knew its location, it became real. Which was why it doesn't matter if the observer's before the gate or after the gate, as soon as it was observed, it behaved as a particle. The bit that twisted people's heads though was it travelling as a wave through both slits at the same time, gets observed and then became the particle, or was it a particle all the way through, i.e. the electron knew it was going to be observed, so always behaved as a particle? What if all particles travel as waves until they're observed? And what actual observation needs to take place for this probability wave to collapse to create the hard particle? The largest problem we have with quantum mechanics or quantum theory, and that's the measurement problem. There's two worlds: a mathematically constructed world where everything's in probability in various locations, and the real world of hard objects and items of matter. Which one's actually real? The measurement problem comes about of we don't actually get to see the collapsing wave. When we see a particle in its location, it's no longer the wave. And this is just one of the issues we have of thinking about things as particles, because they're not really real. When we go back and we look at the standard model, we're not describing particles, we're describing fields. Now, think of a field as a liquid that permeates all of space. When we go back and think about the Planck length in our three-dimensional construct, if we ignore time, and make the Planck length a Planck cube, and now think that these Planck cubes fill up all of space. Okay, it's how we can pixelate space, so let's call them Planck pixels. What we see are the waves being created in these quantum fields as they move through our three-dimensional construct. In one of our Planck cubes, we will find every single one of these quantum fields, and they can have various different energy levels from, let's keep it simple and say 0 up to 11. So we've got all of these fields, they're not like layered on top of each other, they're all existing inside the same field at the same time, and each one will have different energy levels, so it will have different waves. But the Planck cube next to it will be connected, and the Planck cube next to that, the quantum field will be connected. View it like this. When you look at the ocean, you could have a wave that's hitting the east coast of America, and you can have a wave that's hitting the west coast of Africa. Both of these waves are connected, even though there's thousands of miles distance between the two, because they're all connected to the water. Think of the electron field. Every single electron in the universe is connected through its electron quantum field. Doesn't matter the distance, it's just a ripple occurring within that quantum field. So in that aspect, all the electrons that make up my body are connected to all the electrons that make up your body. that make up all the electrons that make up anything that we can see. In that fashion, everything is one and we're all connected. Yeah, this does really sound like hippie shit. Yeah, it does. Yeah, thanks. What I'm going to try and describe next is the kicker to my argument, and it's whether or not you're going to agree or disagree with my analysis of this. Every individual Planck cube can hold every single value for every quantum field we know exists. Let's call it the Planck pixel. My TV, also made up of pixels, can show me any image pretty much at all. I don't go and buy a brand new TV each time I want to watch a new film. I'll just go and get a different DVD, or even better, I'll just go and stream it these days. My TV is capable of showing me every movie that can be played through it. Now, if we think of the universe being pixelated with Planck pixels, they can show any value of the quantum field. So what's dictating the value in the quantum field? Whatever laws are dictating how the fields interact with each other, the universe is capable of showing anything that the quantum fields are able to show, in the same way as my TV would do. Just so happens the universe is currently playing the story of your life. But it's also able to show every other possibility that exists as long as it's made up of quantum fields. Therefore, the fact that it's the story of your life being played is literally 1 in infinity. That's really low odds. The second point we need to look at is the mathematical constructs, or the probability of things existing, far outweigh the real. So again, the odds of this being in existence is 1 in infinity. So the fact you're real is 1 in infinity multiplied by 1 in infinity. So I'm not a mathematician, but that's pretty much close to 0. So the fact that things can exist as a mathematical probability, and all things can exist as a mathematical probability, the chances of it happening is pretty much guaranteed in infinity, at least once. But what if the story of your life hasn't been played yet? We're the DVD still stuck in the box. We have the potential of being shown, we have the potential of being viewed, but it hasn't happened yet. What if everything we're looking at around us is just the probability of its existence? What would a probabilistic consciousness look like? So how have I got on? Have I managed to persuade you that maybe you don't exist? So if this is the type of thing that you really like, hit the subscribe button, because it's going to be so much easier to come back and find this bullshit the next time. But thanks for your time, and if you can f*** off now, because me and him need to have a chat. Thanks a lot.